In this video, we are going to look at complex numbers and operations. I will look at example 1 and 2 in this video, and then I'll make a second video for example 3 and 4. So to start, we're going to look at some definitions. So imaginary numbers are the square roots. They are the square roots of negative numbers. The imaginary unit, I, is the square root of negative 1. Previously, you've learned that you cannot take square roots of negative numbers. The square root of a negative number is an imaginary number. So the square root of negative 1 is equal to I, okay? And then I squared would equal negative 1. So those are two things that are going to be important to remember as we continue through this lesson and when we simplify with imaginary numbers in future lessons as well. So when simplifying the square roots of negative numbers, you're going to simplify using perfect squares and I. And again, I is an imaginary number. So our perfect squares, we've talked about these before, but it's been a little bit. So our perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and this list continues to go on. So perfect squares are numbers that when you square them, the result are these perfect squares. So like 1 is coming from 1 squared, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, and 12 squared is 144. So an example of simplifying square roots of negative numbers, we have the square root of negative 9. Now this could be rewritten as the square root of 9 and the square root of negative 1. We know that the square root of 9 gives us 3. And then we just learned the new definition of the square root of negative 1. The square root of negative 1 gives us I. So when we simplify the square root of negative 9, it's going to give us 3I. So we're going to use that process when we simplify complex numbers in example 1. So example 1, we are simplifying complex numbers. Directions: simplify each expression. So the first one, we have the square root of negative 49. So 49 is a perfect square. When I take the square root of 49, I'm going to get 7. And then I have that negative under there, so that negative is going to give us I. So the square root of negative 1 is I. So my answer is 7I. Square root of negative 121. 121 is a perfect square. The square root of that is 11. And then since I have that negative, I'm going to have I. So square root of a negative 121 simplifies to 11I. Square root of negative 4. Square root of 4 is 2. Square root of negative 1 is I. Square root of negative 50. Now 50 is not a perfect square. So I need to rewrite 50 as a product of a perfect square times a number to give us 50 here. So I'm still going to have that negative. A perfect square that goes into 50 is 25. So negative 25 times 2 is going to give us the square root of negative 50. So I can take the square root of negative 25. That's going to give me 5I. And then the square root of 2 doesn't simplify, so that's going to be part of my answer. So my answer is 5I times the square root of 2. Now I'm going to go ahead and look at the square root of negative 81. Square root of negative 81. 81 is a perfect square. That's going to simplify to 9. And then I have the negative, so it's going to be 9i. Square root of negative 100. 100 is a perfect square. So the square root of that will give me 10. And then since it's negative, I have I. So 10i. There are, let me see, 6 more problems. I'm going to have you pause the video, try these ones on your own, then resume when you're ready to check your answer. So square root of negative 400. 400 is a perfect square. We just don't have it on our list up there. It's 20 times 20. So this is going to simplify to 20i. Then square root of negative 48. 48 is not a perfect square, but I can rewrite it as negative 16 times 3. Square root of negative 16 will give me 4i, and then square root of 3. So 4i times the square root of 3. Square root of negative 40. 40 is not a perfect square, but I can rewrite that as negative 4 times 10. Square root of negative 4 is going to give me 2i, and then I still have the square root of 10. So 2i times the square root of 10. Square root of negative 12. 12 can be simplified as negative 4 times 3. Square root of negative 4 is going to be 2i, and then I have root 3. So 2i times the square root of 3. Square root of negative 27. 27 is not a perfect square, but it can be rewritten as negative 9 times 3. 9 is a perfect square, so the square root of negative 9 simplifies to 3i, and then I have root 3. And then the last one, square root of negative 60. 60 is not a perfect square, but it can be rewritten as a product of a perfect square and a number. Negative 4 times 15 gives you negative 60. Square root of negative 4 simplifies to 2i, so I have 2i root 15. So that is how you simplify complex numbers when you have negative square roots. You have to look for a perfect square. The negative tells you you're going to have an I in your answer. So for example 2, we are going to add and subtract complex numbers. So to add and subtract complex numbers of real and imaginary numbers, you're going to combine like terms. So essentially you're going to treat I like a variable. But we'll learn in example 3 and 4 that when we have certain versions of I per se, you're going to have to simplify it a little bit further. So complex numbers are always written in the form A plus BI. So A and B are just going to be numbers. What this means is whenever you write your final answer, the term with I in it will come last. So here we're going to start by looking at A. So A, we have 4 plus 3i plus 6 minus 2i. When we add, we can just go ahead and combine like terms right away. When we subtract, we'll have to distribute that negative sign first, then we can combine our like terms. So here, 4 and 6 are going to be like terms. 4 plus 6 will give me 10. And then I have 3i and negative 2i. 3i minus 2i will give me 1i or just i. So my answer will be 10 plus I. For B, I have 4 plus 3i minus 6 minus negative 2i. So in this second one, I have to distribute that negative to each term in my second set of parentheses first. So I'm going to have 4 plus 3i. Distribute that negative 6, so minus 6. And then negative times the negative 2i will give me a positive 2i. Now I can go ahead, combine my like terms. So I have 4 and minus 6. 4 minus 6 will give me negative 2. And then 3i plus 2i will give me 5i. Notice how I'm writing my constant first and then the term with I in it second. So it's in that form, A plus BI. There are 4 more for you to try, C, D, E, and F. Go ahead, take a moment, pause this video, and then resume when you're ready to check your answer. So for C, I have 6 plus 8i plus negative 3 minus 7i. I'm adding so I can combine my like terms right away. So I'm going to add 6 plus negative 3, or 6 minus 3. That'll give me a positive 3. 8i minus 7i will give me 1i, or just I. So 3 plus I. For D, I have negative 7 minus 4i plus negative 5 minus 2i. So I have addition, so I'm going to combine my like terms right away. So negative 7i plus negative 7 plus negative 5 will give me negative 12. Negative 4i minus 2i will give me negative 6i. So my answer is negative 12 minus 6i. For E, I have 6 plus 8i minus, in parentheses, negative 3 minus 7i. I'm subtracting, so I need to distribute that negative first. So I'm going to have 6 plus 8i. The negative times negative 3 will give me a positive 3. Negative times negative 7 will give me a positive 21i. Now I'm going to combine my like terms. So 6 plus 3 will give me 9. 8i plus 21i will give me, where did I get 21 from? Let me backtrack for a second. I apologize for your notes. That should be a positive 7i. I think I went and multiplied by accident. So again, sorry for your notes. That negative times negative 7i will give you a positive 7i. So now I have 8i plus 7i. That will give me 15i. So your answer is 9 plus 15i. F, negative 7 minus 4i minus negative 5 minus 2i. So I need to distribute that negative to the negative 5 and negative 2i. So I'm going to have negative 7 minus 4i. Negative times a negative will become a positive, so positive 5. Negative times negative 2i will give me a positive 2i. Like terms, negative 7 and 5. When I add those together, I get negative 2. Negative 4i plus 2i will give me negative 2i. So negative 2 minus 2i is my answer. So this is just examples 1 and 2. In the next video, I'll go ahead and do example 3 and 4. So please make sure